Okay, so let's actually start doing some of these problems. So A, I have the absolute value of 6k plus 5 is less than or equal to 13. The first thing that you have to ask yourself when you are doing these problems is, do I have an and or an or? So you look up back at your notes and you will see this is a less than. That means I want less solutions, less than. So this has to be an and. I want it stuck between certain amount of solutions. I want them stuck between negative 13 and 13. Whatever's in here has to be stuck between those two numbers. So again, I like setting it up all as 1. So I know it has to be greater than negative 13 because all these answers could include 0, 1, 2, 3, and negative 1, negative 2. But they also have to be, and both of these should be equal to, less than or equal to, that they have to be less than positive 13. So it can be 12, 11, 10, all of that. Okay, then we are just going to solve these just like we have been practicing the last couple of lessons. So when I subtract the 5 in here, not only am I going to subtract it to this 13, but I also have to subtract it to the other side. Remember, you want to keep this inequality balanced on both sides. So negative 13 minus 5, I'm going more negative, so that's going to be negative 18. Has to be less than or equal to 6k, which has to be less than or equal to 13 minus 5 is just 8. Okay, and then we are going to divide all of these by 6. So I got to divide the 8 by 6. Also have to divide the 18 by 6, negative 18. Negative 18 divided by 6 is just going to be negative 3. I did not divide by a negative number, so these inequality signs are going to stay the same. And now I have to simplify this fraction. So 8 over 6 is just going to be 4 over 3, or that's about 1 1/3 if you want to look at it that way. All right, so now I know that k has to be between these two numbers. So k can still be 0, it can be 1, it could be negative 2. So, and if you're ever unsure, just plug it back into here. So the easiest one would be to just plug in 0. So if I have 6 times 0, and then that's just 0, 0 plus 5 is 5, 5 is less than 13. If I wanted to plug in 1, because this is 1 1/3, 6 times 1 is 6, plus 5 is 11, 11 is still less than this. If you wanted to plug in negative 2, because that's in between these numbers, that would be negative 12 plus 5, which is negative 7. But once I take the absolute value of negative 7, that's positive 7, still less than 13. Okay, so that means all of these numbers are going to work. So when I go over here, I have negative 3, negative 2, negative 1. Oops, that's just supposed to be 0. And then I have 1, and then I have 2. Let me fix that real fast so it doesn't look like a circle. Okay, and now I'm going to have closed circles on both of these. So 1 1/3 is going to be somewhere right over here. And then I have negative 3 right on the dot, closed circle. And I know it has to be in between here. So I want everything in between these two numbers. And then I just have to do my interval notation. So again, I'm always going to read it from left to right. There's nothing getting shaded over here. So it starts at 3, negative 3. This is a closed circle, so I want the bracket. And then it goes to this 4/3. And I can just write in 4/3 over here because I want exactly 4/3, the 1.3 repeating decimal. I want all of that. And I want it both in a bracket. Okay, let's not waste any more time. Let's go on to part B. This one, an absolute value of 9 minus 2w is less than 3. So again, it is less than, that means I want a less number of solutions. That means whatever's stuck inside here has to be between 3 and negative 3. So again, I want an and. Okay, so I'm going to set this up the same way that I set it up over here. Always put the negative on the left side. So remember when you were just solving absolute value equations, we would always set it equal to 3 and negative 3. But now the absolute value ones, I always want that negative number on the left. And then since this guy does not have an equal to sign underneath it, neither of these guys should. Your inequality signs are always pointing to the left because I want it greater. This has to be greater, so the alligator should be eating the middle thing. I want it greater than -3, but I want it less than +3, so the alligator should not be eating this for the +3. All right, so anyway, I'm going to start with a 9 because that does not have the W attached to it. I have to subtract that 9 everywhere. And then I'm going to have -12 is less than -2W, which is less than -6. Then I'm going to divide everything by -2. All right, now pay attention to this over here because now I'm dividing by a negative number. So I am going to have 6 over here, but I have to flip my inequality signs because I am dividing by a negative number. So those rules, whenever you're dealing with inequalities, they still apply if you're multiplying or dividing by a negative number. So that's going to happen to both of these guys. And if you didn't catch that right away, here's another way that you can tell. So notice over here, now my greater number's on the left and my lower number's on the right. Okay, so whenever that happens, that means you should be flipping your inequality signs because eventually I'm going to have to flip this whole thing back around. I always want the lower number on the left side and the greater number on the right side. So I want to take that whole thing and flip it back around. So my lower number 3 is going to be on the left. And when I flipped everything around, notice how the 3 is less than the W. It's the alligator's eating the W over here. I still want the alligator eating the W over here. And then that has to be less than 6. So notice how the alligator's eating the 6 in this case. Oops, sorry. All right, so then that is how you turn it around. You have to flip everything around. The W is the only thing that's really staying in the middle. Okay, so now we can go and graph this. This should be pretty easy to graph. So we have 3, 4, 5, 6. Okay, none of these have the equal to underneath them, so both of these are going to be open circles, and I want everything in between. And again, if you are ever not sure if that's going to work, you can just pick a number in between here. So you can pick something like 4. So if I do 9 minus 2 times 4, 9 minus 8 is 1, absolute value of 1 is just 1, and 1 is less than 3. So if you're ever unsure if you did it right, just take a number that you shaded in and plug it back in and see if it works. Then I am just going to read my number line. So I'm starting with 3 and I'm ending with 6. They both have open circles, so that means they both get parentheses. All right, let's do 2 more examples. So I'm going to turn my page. Okay. So my next one is going to look something like this. So now I have the absolute value of 4c minus 7 is greater than 6. Okay, so now I have to ask myself, what kind of compound inequality do I want? Do I want less than or greater? Or do I want an and or an or? So this one is great or. It's eating the absolute value. So I want a greater amount of solutions. Remember, what's inside here can be 7, 8, 9. It can also be -7, -8, -9. So it can be anything that's greater than 6 on both the positive and negative scale. So this has to be an or. It's a great or. I want great or number of solutions. And you can also think to yourself, can I plug in infinity to here and make it true? And that answer is yes. Okay, so whenever you can plug in infinity and it makes it true, that means you're going to be dealing with an or problem. All right, now when you are setting these up, you can't set them up the way that we did the last time. These must be 2 separate inequalities that you're setting up over here. So I always want, and you don't need the inequalities or the absolute value bars anymore. I always want the negative on the left side because that's just how my number line is going to work. And I want it to be less than the negative. So remember, like over here, it can be like -7, -8, -9, -10. Okay. And then I'm going to set up the same exact thing, but now I'm saying it could be more than positive 6. Okay, before we start solving these, let's just take a look at these really fast. There's a couple of different ways that you can tell if you set them up right. One, as long as you put your negative on your left and your positive on your right, your arrows for ORs should always be pointing away from each other. So remember how you usually shade out for ORs? That means this one should be shading this way, this one should be shading that way. That's one way that you can tell. The other way is whenever you have these problems, this original one is always going to show up in here. Notice how this and this is exactly the same. I just took the absolute value bars off of this one. So this one is always going to stay, and it's always going to stay to the right. Okay, so the negative one goes on the left, and you flip your inequality sign because I want less than the negative one because it's going to go towards negative infinity. This guy always stays the same. So I want greater than the positive one because that's going to go towards positive infinity. So just make sure those pieces are connecting in your brain. Okay, and then we can just go and solve these, and you know how to solve these. So I'm just going to add 7. 4c is less than just 1. Divide by 4. And I have c is less than 1/4. And that's for one of my solutions. And then over here, still add the 7. 4c is greater than 13. Divide by 4. And again, I can just leave it 14/3 since that can't be simplified. I'm sorry, 13/4. You can tell I'm a little bit out of it. Okay. 13/4. I apologize. Okay, so now 1/4, obviously between 0 and 1. 13/4. 4 can go into 13 3 times. So that's just going to be 3 and 1/4. So sometimes I just like to write that down just so I know where to graph it, because when you guys are graphing these, I don't like you to put just 1/4 and 13/4 on your number line. I want you to actually put whole numbers on your number line and then just kind of tell me where they are. So I'm going to start over here with 0, 1, 2, 3, and then that is 4. And both of these do not have the equal to signs underneath them, so they're both going to be open circles. So 1/4 is going to be somewhere over here, 3 1/4 somewhere over here. And then I want everything that is less than 1/4. So I'm going to shade out this way. And I want everything greater than 3 1/4. So I'm going to shade out this way. So since it's an OR, that means you should be shading out. That also means when I go to write my interval notation, I should have 2 sets. So I'm going to start reading from the left. So I always start at negative infinity over here. And then I'm going to 1/4. Open circle means parentheses. Skip over all of that stuff. I continue at 13/4, and it still gets a parenthesis, and then I'm going all the way to positive infinity. So that is how you write your interval notation. Okay. I'm going to do one more over here before I stop this video. If you want to pause it after I write it down and see if you can actually set this up by yourself and see if you're doing it right, that would be great. So I have 2/3 t plus 2 in absolute value bars, and then I have a -1 on the outside over here, and then is greater than or equal to 3. Okay, so this is going to be pretty much exactly the same as like when we were just solving regular equations. You have to make sure this absolute value is by itself before you can even decide if it's an and or an or. So the first thing that has to happen is this 1 has to go away. So I'm going to add 1 to both sides. And then I'm going to have, I still have those absolute value bars because I didn't decide what I'm doing with this yet. But now it's going to be greater than or equal to 4. Now that this absolute value is by itself over here, it's isolated on the left side. Now I can try to ask myself if I'm going to have an and or an or inequality. So this is still a greater than sign or a greater than sign, which means I want more number of solutions, greater number of solutions. And both of them can go to positive infinity or negative infinity because obviously both of those are going to be greater than 4 once you take the absolute value of them. So now I can split it up into my two different inequalities. So remember, this exact thing is always going to go on the right. I don't even have to change anything. It's going to be greater than positive 4. That one always just stays there. The left one has to change the sign because it wants to be less than negative 4. So another way to think about this, if you're changing the 4 to a negative, that means you have to change the sign too. So this one gets to stay exactly the same. Once you change one thing over here, like adding the negative, that means you have to flip the sign too, because you want these inequalities facing away from each other. You want them pointing out. The negative one is always on the left. So just try to remind yourself of those hints when you're doing your homework. Okay, let's go and solve these. So we're going to subtract the 2. 2/3 t is less than or equal to negative 6. And then I'm going to multiply by the reciprocal over here. So 3/2. I am not multiplying or dividing by negative, so everything gets to stay the same. So I'm going to have t is less than or equal to, and I always like using my trick. So negative 6 divided by 2 is negative 3 times 3 is negative 9. You can also just multiply across. Negative 6 times 3 is negative 18. Divided by 2 is negative 9 still. And again, it doesn't matter if my answer is negative. I didn't multiply by a negative, so my inequality still is true. So I'm going to move over here, subtract the 2. 2/3 t is greater or equal to positive 2. Still going to multiply by the reciprocal. So t is greater than or equal to 2 divided by 2 is just 1, and 1 times 3 is just 3, or you can do 6 divided by 2, doesn't matter. Okay, so then I'm going to have this. And again, your negative number is on the left, and it should be less than that lower number. Your positive number is on the right. It should be greater than that one. So always just make sure, like, this sentence makes sense. Okay, and then we're going to go and graph this. So I have negative 9. I'm just going to count by 2s. So negative 7, negative 5, negative 3, negative 1, positive 1, positive 3 is over here. Okay. All right. So since both of these are less than or greater than and equal to, that means I have closed circles over negative 9 and positive 3. I want everything that is less than negative 9. I want everything that's greater than positive 3. And then again, if you are ever unsure if you did this right, you can always plug it back into the original problem. So say over here, notice how 0 is not getting shaded. That doesn't necessarily mean that you can't plug in 0. It's just 0 should give you a false solution, because I just like plugging in 0 just because it's the easiest number to plug in. So let's go back to this original problem, just plug in 0. 2/3 times 0, nothing. Nothing plus 2 is just 2. Absolute value of 2 is just 2. And then I have just 2 minus 1 is 1. 1 is not greater than 3. So again, I plugged in a number that was not getting shaded over, and it made it a false statement. 1 is not greater than 3. So that means I probably did this right. If you want to make sure, you can always plug in 4 or 5 or negative 10 or whatever like that. And you can always do that on a test or quiz just to make sure that you're doing it right. All right, but let's just finish this problem. So I'm starting with negative infinity over here. I'm going to negative 9. Negative 9 has a closed circle, so I want a bracket. Skipping all over that stuff, I'm starting at 3 with a bracket, and then I'm going all the way to positive infinity. Okay, so there are your solutions in all three forms. Remember, on a test, I am going to want all three forms. You have to give me your inequality solution, your graphical solution, and your interval notation solution. Okay, one more video coming up. Hopefully this is making sense. If it's not, start writing down questions to ask me in tomorrow's lesson.